Good morning, good afternoon, or good evening, depending on when you're watching this. Now we're moving on to a new topic today, and the topic is expressing the function a cos x plus b sin x in some other form. Functions of these forms occur frequently in applied maths, and it's very useful to be able to transfer the expressions to some other containing only one trig ratio. So let's look at the example on the board. We are being asked to express 3 cos x plus 4 sin x in the form k cos x minus alpha. In other words, we're taking a function that contains two trig functions and we're going to write them in terms of only one. So let's do that. It's a typical exam question. So it says express that in the form k cos x minus alpha. So the first thing we would do is to make it equal to that. So let's do that. 3 cos x plus 4 sin x is equal to k cos x minus alpha. So we're saying these two things are equal. Now the next thing you would do is use your cosine expansion. So let's do that. 3 cos x plus 4 sin x is equal to our cosine expansion. Now that's given on your formula sheet for cos A minus B, and that is cos k cos x times cos alpha plus k times sin x times sin alpha. So that's your first thing. You've got to do your expansion. Now these things are equal. We've got 3 cos x here, so I'm going to underline that. There's cos x, 3 cos x, and here is cos x here. Now that is, the coefficient here is 3. So it's 3 cos x. And the coefficient here is k cos alpha. So I can write down 3 cos x is equal to, because we could write that as k cos alpha times cos x, so the coefficient here is 3 and there is k cos alpha. So do you agree we can write k cos alpha is equal to 3? Now let me underline, let's look at the other one, and here we've got sin x. So I'm going to underline sin x and sin x here. Now here I've got the coefficients plus k times sin x, and here the coefficient is plus 4. So do you agree then that it's plus 4 sin x and plus k sin alpha sin x? So matching these up, we can say that k sin alpha is equal to 4. Now what we're going to do now is square both sides. So I'm going to square that and I'm going to square that. Now that's k cos alpha times k cos alpha, so that would be equal to k squared cos squared alpha. 3 squared is 3 times 3 is 9. Now I'm going to do exactly the same thing here. I'm going to square both sides. And that would give me k squared sin squared alpha is equal to 16. Okay, now I'm going to write k sin squared alpha plus k cos squared alpha is equal to k sin squared alpha is 16, k cos squared alpha is 9. So I'm going to write that as 16 plus 9. I'm going to take out, sorry, this should be k squared. Let's go back and do that. I'm now going to take out the coefficient of k squared, so k squared, and in brackets sin squared alpha plus cos squared alpha is equal to 25. Now, sin squared alpha plus cos squared alpha is equal to 1. That's something you knew from Nat 5, and certainly we've used it lots of times this year. Sin squared alpha plus cos squared alpha is equal to 1. Sin squared A plus cos squared A is equal to 1. That's something you should absolutely be aware of. So let's just highlight that. That's equal to, okay, so that's what we've used there. So that would be k squared times 1 equals 25. So we can write that as k squared is equal to 25. So k is equal to the square root of 25, and k is positive, so k is equal to 5. So we've found the value of k. The next thing we have to do is to find the value of alpha. And again, let's do that. Let's write that as k sin alpha over k cos alpha is equal to, now k sine alpha we've got up there is 4, so that k sine alpha is 4, k cos alpha is 3, so 4 over 3. Now we're going to cancel, that k cancels, and we've got tan alpha, that sine alpha over cos alpha is equal to tan alpha. And again, that's something we know from Nat 5, and again, something we've used this year, sin A over cos A is equal to tan A. So we can write that as tan alpha is equal to 4 over 3. Okay, so these are facts that we've used from Nat 5. So this means tan alpha is equal to 4 over 3. So if we're working alpha out, alpha would equal the inverse tan of 4 divided by 3. Now, which quadrant does this lie in? Again, if we can go back, we know that we've got all sine, tan and cos. This is easy because they are all positive. The sine, the cosine and the tan are all positive. So it's going to be the first quadrant. But generally what we're going to do is we're going to look at k cos alpha is equal to 3. Now since k is positive, cos alpha is positive. So if you were solving cos alpha equals a positive number, you would say, what quadrants will my answer come from? The first quadrant or the fourth quadrant? If you are looking at k sine alpha equals 4, k is positive, so sine is positive. If the sine is positive, which quadrants can it come from? The first or the second? And since we've got the 2 ticks here, it's the first quadrant. Now, that's easy here, they're all positive. It's later on this will become more significant. So we have here, if you put that into your calculator, inverse tan of 4 divided by 3. If you put that into your calculator, you'll get alpha is equal to 53.1 degrees. So let's finish that off. We started by saying that 3 cos x plus 4 sin x was equal to k cos x minus alpha. We've found our values, so 3 cos x plus 4 sin x. We worked out k to be 5, so 5 times cos x minus alpha is 53.1. So we have successfully written that in terms of one trig function, in terms of the cosine function. Okay, we've worked through one example, and really it was from first principles, if you like, showing you step by step why each thing was the case. Now, it's not the way it's required by the exam board. What we're going to do is we're going to do an example, and I'm going to set it out exactly the way the exam board. Now, there's no exam board this year, but there's a marking scheme supplied by them. So it's exactly the way the exam board or the marking scheme demands to achieve full marks. Now, you can throw away lots of marks in this, and I see it every year as a marker. So really important that you set it down exactly as I'm showing you. Now we have here our example, express 3 cos x plus 2 sin x in the form k cos x minus alpha. It's absolutely crucial that you do not write k equals the square root of 3 squared plus 2 squared. You will get no marks if you do that. The exam board look for you, first of all, to make them equal to one another. So if we do that, let's start by doing that. We would have 3 cos x plus 2 sin x is equal to k cos x minus alpha. That's the first step the exam board want to see. And the next thing they want to see is your expansion of the cosine cos x minus alpha. So let's do that. So we would do k cos x cos alpha plus k sin x sin alpha. Now if that is missing, you are throwing away marks. The next thing you want to do, and again, they award a mark for this. If you do not do this, you are throwing marks away. So here we have cos x, and here we have cos x. The coefficient here is 3, and the coefficient here is k cos alpha. So we can write then that k cos alpha is equal to 3. K cos alpha is equal to 3. And we're going to do exactly the same thing with the other side. So here we have, I'm going to underline this, sine x, and here we have sine x. Now in front of this we'll be plus k sine alpha and plus 2. So we match these up now. Let's do that. We've got that k sine alpha is equal to plus 2. I'm just going to write down 2. K sine alpha is equal to. So the exam board demand all of that is in there. After which you just go to k is equal to the square root of 3 squared plus 2 squared, because the steps that were in there in the previous example were to convince you that that was the case. The exam board looked for this. So we have established the value of k. K is equal to the square root of 13. The next thing you want to do is find the value of alpha. And we do this as before. K sine alpha over k cos alpha. K sine alpha we have there is 2. K cos alpha is equal to 3. And again, we're going to these are common factors. So we're left with sine alpha over cos alpha, which we know is tan alpha. So tan alpha is equal to 2 over 3. Again, they are all positive. It's in the first quadrant. So alpha is equal to the inverse tan of 2 divided by 3. And if you use your calculator this time, you'll find that alpha is equal to 33.7 degrees. Now let's write that out. We were asked to express 3 cos x plus 2 sin x in the form k cos x minus